Hello, everyone. Thank you for joining us for with tonight's TwinCities.net user group, where Tony will be speaking to us about admittance to Azure. Tony is a close friend of mine. We were in Tech Masters for a number of years. He has served as an architect. He has many certifications, some that I'm very envious of. However, without that given, I'm going to introduce Tony and turn it over to him. It's all yours, Tony.
Thank you, William. Okay, let me click here. All right. Today's speech is called Admittance to Azure and talking about securing the entryway. I've got a quick summary here, a nice agenda slide. I'm going to go through these very fast. Feel free to jump in with questions, and I'm also leaving time at the end for questions. About me. You can see I've got a number of big certifications. I'm also very active with the Minnesota chapter of the Association of Enterprise Architects. That's my side job. And then most Tuesday mornings I try to make it to Tech Masters. I just started a new position with Wolters Kluwer just this week. And when I checked their website, there are a couple other positions similar to mine that they're advertising. So feel free to reach out to me and I'll happily see if we can get more people employed. I like the company so far, but just as an aside, all my opinions tonight are mine. Let's go back and talk about some of the security basics. When you're building out a cloud application, you need to keep in mind security. How do you get in? Are you going to build a nice castle gateway, or do you wind up with something looking like the gate there, which could just as well be a ladder for the intruder to climb over and get into? In security, we have this thing called the CIA triad, which says you need confidentiality, integrity, and availability. Confidentiality, only those people who are supposed to see it see it. Integrity, it's the information is correct. Well, is correct to what you put. It doesn't get changed. Availability means it's available. And these are sort of three attributes that we need to keep in mind as we build a website or a cloud application. Another thing that we should think about is the OWASP top 10. This is one of the better categories to think about. 10 things. Here are sort of the top 10 items, vulnerabilities that they've discovered in doing extensive interviews. They do these polls every 3 years, and you'll notice in here, I made it. Some of these have been on there for a long time. Broken access control, the top one, has been on there since 2017. Security misconfigurations, again, since 2017. There's a couple ones that are relatively new, like number 10, which is brand new this year about not handling exceptions correctly. But those are things that you build your tools and do those properly. Now, we'll move on and look at doing a networking refresher. And we only have one real slide here, and that's about the OSI network model. And I've included a couple of little things on the very right of the right hand, some of the equivalent things in AWS. But networking traffic gets handled at multiple layers, but the layers we're going to be most interested in are layer four, and I've got my slides misaligned a little bit. I need my load balancer to move up a level. And then there's the app gateway that's up at level 7, which is a different style of routing, and we're going to get into more of that. And then you've got using DNS and Traffic Manager that you can turn on those are different ways to control access to your site. So let's start out with the simplest style of routing called DNS-based routing. And it's not a true network layer. When someone gets your domain name and looks it up, where do they get sent? And DNS-based routing sends you to different places based on many different criteria, and we'll talk about a few of those in a moment. Sometimes you might even want to use this, and you may want to use this for things like if you've got multiple regions and countries and you with sites in different countries, you may want to use DNS-based routing to direct your customer to the appropriate site. One of the problems or drawbacks that you can stumble over is failover might be slow if you set your time to live too long. By time to live, that's how long your DNS name, the lookup remains valid. So when you go to the DNS, it says this location is valid for some period of time. That could be days, hours, or in some cases, you can set it down fairly low if you really want to have a fast failover. In Azure, we have a thing called Traffic Manager. Traffic Manager, and I'm not going to read everything on the slide, but Traffic Manager is basically a way that you can point the host name that you've set up to different locations and then send it based on one of the routing methods listed there. Priority. You want one particular location to take priority. Weighted. You're distributing it based on a weight. Performance. Send it to the thing that'll get the response back to the caller quickest. Geographic. Use their location. There, and then the bottom one, subnet, uses the caller's subnet. This is an example of a priority routing method. You've got three different sites listed in there, priority 1, 2, and 3. And for some reason, the health checks for your primary site are degraded or not good. And in this case, it fails over to your secondary site. Performance-based. You use the latency of the site to determine where it goes. My latency in this case is different and based on where you're located. And I think must be a health check in here because this was the site. This is directly from Microsoft's literature. In this case, of the two sites that are available, North Europe and East Asia, North Europe has the lowest latency, and that's the one that it will choose to use. If endpoint 1 were healthy, it would send it over to West US. And there are some alternative, and I'm not going to go into all the methods, but those are just two of the most common. There are some third-party alternatives, and I'll interject. If you're a multi-cloud vendor, you could use AWS Route 53. It's a great tool. It's got a lot of the same routing logic types of logic that Azure offers. And if you're multi-cloud, maybe, and you're already using that, hey, don't need to do everything in Azure if you're multi-cloud. Cloudflare. I think we've all heard that of that one. Not only does it do DNS-based traffic management, but it's also got a lot of extra things like a CDN or content delivery network, and we'll get more into that later. DDoS protection and a WAF, web application firewall, which can preview a lot of your incoming requests against things like the OWASP top 10 to watch for some of those common errors and attacks. Akamai Edge is another one. Well, in doing my research when I updated my slides, these were sort of the top three on my list. You can do routing at layer 4. Layer 4 is basic TCP or UDP or a number of other protocols that are at that layer of the network stack. However, if you're sending HTTPS traffic through here, you have no visibility inside the packet, and you can only route based on the URL path or on the IP address, although there are some tricks I think that I've seen allow some times optional routing, but the advantage of layer 4 is it's very high throughput because it just sends everything to one of the back ends. It accepts it at a single IP address and protocol and sends it to the back end based on whatever your internal criteria are. All of your TLS handling, authentication, authorization, and things like that do need to be handled by your back end. And there's a few suggestions. And one thing to think about is in layer 4 routing, your traffic remains encrypted in flight. So if you're using TLS or SSL as it's more often commonly called, it remains encrypted. Azure's mechanism for this is the load balancer. And for an Azure layer 4 load balancer, all of your sites need to be, all of your backends, targets need to be in the same virtual network or same region, well, within Azure itself. Here's the simplest configuration. Your traffic comes in, hits the front end. You can use network security groups on the network, on the VNet or subnet that holds your load balancer to prevent, say, types of calls to ports you don't want open. And it uniformly sends it to an appropriate backend, which could be a Windows VM, Linux, app service, scale set. Load balancer is a you can start mixing and matching. You could use a traffic manager in front of two load balancers within different regions. This would be a nice way to provide some, so if region 1 ever went out, Region 2 could pick up and take over. And this is lower cost than what's called a global load balancer, which is on our next slide. Well, in the last couple of years, Azure introduced the cross-region load balancer, which sort of sits out at a higher level and then routes to a load balancer at one of the back ends. So this would be one way to have a single global IP for all of your websites across the world and to route it. Layer 7. Layer 7 is what happens after you've handled the SSL certificate. You have to install your certificate directly on your layer 7 load balancer. Your incoming traffic gets decoded, but that makes a lot of things become visible, such as a host header. So if you have 12 different sites with different names, those different names become visible. Or if you want to send some traffic to, let's say, an images folder to one server and the rest of it to a different server, you can do that because the router has full visibility. And typically, you can do things like URL rewriting. So your incoming URL gets modified to something more appropriate for your back end. And you can include a WAF, which is a web application firewall. And typically, a WAF can be used to eliminate and guard against some of those most common attacks. And here's a better definition of what a WAF is. I'll give everybody a few seconds to take a look.
Hey, Tony, would you
Yes.
like questions during your presentation, or do you want us to hold them until the end?
If somebody has something really urgent, feel free to jump in. Otherwise, I did plan to leave time.
Okay.
All right. Here's your Azure Application Gateway is the tool that is used to that Azure uses for layer 7 routing. If you have an on-premise server right now, you may be using something like Cisco or F5 for your to do this. And you can include in Azure, you can add a WAF at this level to start adding some extra protections against common web attacks. Here's your example. Here's an example of a possible setup. The users connect to your website, and you could actually have multiple websites. You might have app 1, app 2, app 3 all in the back end. Or you might even have maybe you use app1.myhost.com dot myhost for the host name and app2.myhost and extract that name and send it to an appropriate backend service. You can also this also works. App gateways are also meant to work as ingress to Azure Kubernetes, and you can also set up WebSockets. So if you're using one of those high intensity push-pull type socket-based connections where you have that long-lived connection, app gateways are another are a good thing to consider. And of course, you could combine with Traffic Manager, or as an alternative, you could even put your layer 4 global load balancer on outside and let it route to one of the appropriate regional backends. But setting up an app gateway this way would be a good way to have, especially if you need to maintain high availability with the requirement that you survive whole region failures. Then there are a number of third-party alternatives. F5's got both an IP. You can deploy an F5 switch. Azure has a way to set up an F5 switch in your Azure account. That lets you migrate all of your existing F5 rules up to the cloud. Nginx has both. You can deploy it to a VM or you can use a managed service. Nginx as a service. And Nginx actually will support both layer 4 and 7. And then another popular open source product is HA proxy. So these might be alternatives depending on your use case. Maybe you're already using it in your move to the cloud. You may want to consider one of these. Here's another alternative to look at is something called Azure Front Door, which is a content delivery network. Front Door, and if you're interested, AWS has its technology called CloudFront, and I expect Google and Oracle's OCI both have something similar. But in this instance, Azure sets up a series of locations across the world and it directs your traffic to whatever the nearest location is. And there may be many, there might be multiples within a given region, that you do need to put your certificate out there on install it into Front Door. And then Front Door will pick up the application and it can direct to an appropriate backend. And that could be on-premise legacy servers. That could be, well, you might even you got Azure Front Door, you might direct it over to Google, GCP, or AWS or something. Or, of course, it's optimized to work with Azure. It also does a lot of things like caching. And you can again turn on the web application firewall. So here's an example of setting Front Door up with multiple locations, backends, and they're with appropriate health checks and caching. So this is a great technology to accelerate access to your website and let Azure take over some of that caching for you. There are third-party alternatives. Again, Cloudflare. Cloudflare sits out at its own endpoints all across the world, and it includes that CDN acceleration, DDoS protection, advanced WAF services. You can actually write helper code, little code snippets in JavaScript that will run on the Cloudflare to do things. I actually, when I was one of my previous jobs, we set up Cloudflare and we needed a way to support mutual certificates. And since the certificate decode takes place at Cloudflare, we had to be able to extract the client certificate information and forward it on so that the application could authenticate. Akamai has a similar global CDN. F5's got a distributed cloud version, and these all support all three of these third parties support multi-cloud architectures. So if you're one of those companies that, well, let's say you're a big enough you're, and typically this happens with a big company. Division A goes with Azure, Division B maybe goes down the AWS path, and now they try to centralize everything. Well, neither division wants to give up and migrate to the other's cloud. So this can actually provide a great alternative in that instance. And the other thing to think about is if you're building APIs, maybe you want to consider API management or an API gateway, setting up a gateway specifically for your APIs. There's a lot of good stuff that it provides. You can do, I actually, at one of the other companies I worked at, we would extract information from the URL and pull out like part of the host name because what we had one was one of the for this application we were using a pattern of client name dot mycompany.com as the target. And so we'd extract that client name and put it into the header, pass it on, and that would tell our backend services which client we're working this particular request was for. And so you can do things like that. There's other things you can do with it. This will also handle a lot of your authentication. So you come in with that you come in with that OAuth token. You can actually have the gateway validate it. There's a list of benefits and drawbacks. A couple of the drawbacks that I'll highlight. Azure API management does not incorporate a WAF. If you want a WAF with API management, you need to use one of the other technologies in front of your API management. And the other thing is that API management is, as it's named, meant for APIs, not for general web traffic. So if you want to serve up all of your images and your web pages, this is not the application for you, but this is a great place to put your APIs. And there's a number of third party alternatives and even or alternatives. You could use your app gateway because it can do a lot of the decoding similar to your app gateway or the API gateway. And you can have either app gateway or front door handle it. Nginx has an API gateway. Kong Gateway and Tick Technologies both provide API gateways that can be installed easily in Azure. So you're not limited to Azure. to the Azure native tools, but sometimes it's convenient to use Azure. Sometimes that's just what's most convenient. Yeah. Some other considerations in building your website. One of the things that if you want to build out a good application, if I went back to the picture of the castle gateway, you need to build the appropriate walls. You need to set guards in place, and that's your network service groups or application service groups to tightly control how you communicate. Something else to think about is zero trust. When you're dealing with SSL, whatever place your certificate gets checked and validated against is where you have to have your certificate installed. And at that point, it decrypts all of your SSL traffic. So your app gateway decrypts the traffic. Cloudflare will decrypt the traffic. And it's up to you to appropriately use internal certificates between the front end that gateway, that portal that you've set up, and your backend services. So you may want to have internal certificates within place so that we don't get into that approach that people can come in if they slip by the front door, if somehow they slip past that front entry portal, your doors inside are still locked. And the damage that an attacker can do is much less. Keep your database and other connections secure. Whenever possible, especially for SQL Server-based connections, use managed identities. A managed identity, and and there's two varieties. You can manage it completely yourself, or you can let Azure generate and manage the identity for you. But that managed identity is like a user, and there's no password ever passed back and forth between your application and the database for any of the backend services that support managed identity. Application security groups, or ASG, are another way to say supporting I'm I'm looking for my incoming traffic to come from a specific location. You can also use your network service group if you put your database in a separate network, only control who can actually open those network ports. It can only come from these certain subnets, other subnets. Good secrets management. Keep your secrets secret. Azure Key Vault. I think you could also use Hashi's Vault and install that on a VM in your net within your cloud. But keep your secrets secret. Don't ever let you don't ever let a password or a secret credential type thing be checked into your Git repository. Put in place scanning tools to check for things like that. And this talk tonight is focused on securing your inbound phase, what options you have for the inbound phase, and some of the ways you can secure it. But you also need to think about outbound connections. If somebody gets in, what data can if an attacker got in, what data of yours can they send out? That can be a problem. Lock down the outbound connections and only allow certain outbound locations to be reached. There's no reason that your backend website or your backend application needs to reach out to some random web server someplace out on the internet and send data to it unless you've identified that target as providing a service you need and have built appropriate safeguarded connections. Other things you may need to put in place are DLP monitoring, data loss prevention, put a cloud access security broker in place, monitoring for endpoint extended detection and response. I think if you work in a corporate environment, you may have something like CloudStrike installed on your laptop and on all of the web servers within the cloud to monitor what you where you can connect to and also to safeguard what information gets out. So, quick review. You can use DNS-based routing, Traffic Manager, or one of the third-party alternatives. You can use layer 4 routing, which is pure TCP. Your TCP packets come in and get redirected. Your TCP or UDP packets can be directed. However, your OWASP type security needs to be done at the application level in this instance. Layer 7 routing lets you install your certificate on the app gateway, front door, Cloudflare, decode and take actions based on the contents of the message because in a straight HTTP TCP connection, the only over SSL, the only thing that's visible is the target IP address and the size of the packet. I think there are some modern alternatives that I've seen where the host name can be extracted and passed separately alongside your layer 4 message. But that was a new one when I was doing the research, and so I didn't put much about that in here. But so an Azure App Gateway is great for supporting multiple sites. And so let's say you're supporting each of your divisions has its own website and service. You can use one Azure App Gateway and based on the host name, route to an appropriate backend server. Azure Front Door is great. It provides some similar capabilities, but it adds in content delivery at nearby points. API management. Of course, Azure's API management does not include WAF protection. But the important thing is that you can mix and match and combine the various points above. There's many ways to secure your entry, and you can layer it at different layers of the network stack, and you can use the Azure internal tools, the native Azure native tools, or you can use third party. Which one should you use? What's your use case? Sit down, do a close analysis, and decide based on that combined with the cost of each service versus its individual benefit. And I think I have reached this Q&A period. Questions?
Not a question, but having gone through the Azure Certified Administrator course, this is a nice refresher, Tony. There's a lot of networking stuff in that Azure Certified Administrator course.
Yep.
May I ask a question?
Sure.
So, Tony, thank you very much for a wonderful presentation. It's very informative. And as a professional, if you, um, get involved in architecting something like that, what will be your approach to choosing the appropriate level of security and the things that are put in place?
It comes down to doing some threat modeling. What's your risk appetite? How much risk are you willing to accept? How much risk is the business willing to accept? I've seen a couple great illustrations of choosing solutions. You can, and this gets into risk management. Risk can be, you can quantify it in high risk, low risk, or high risk. How likely is this to occur? Low risk. It's not very likely. High risk, it's very likely, and you're probably going to see it happen. Combine that with impact. How much damage will it do? What type of data are you protecting? Do you have a lot of sensitive financial data or personal health information, PHI? In that case, you probably need to consider that the impact of a breach will be much more serious, and so you want to build up a bigger, badder front door. But then again, if it's a very low impact, if it's something that's very low impact, even if it's very likely to occur, you may not want to spend a lot of time dealing with it. But that's where you need to do a risk assessment and think about those aspects. I could do a whole separate talk on that. I've actually got some notes on that. I started to put together a Risk 101 class for my at Tech Masters. But the key thing is make your security application fit what you're protecting and the likelihood and how likely an attack is going to be and how impactful that impact will be. So a simple front door of you're putting a standard deadbolt on your front door might be good enough for most people's houses. However, if you've got lots of high value equipment, you may need to think about putting a much more heavy duty door in place. And instead of that $50 lock from the big box store, you may want to spend the money on the $300 deadbolt from a locksmith. What are you protecting? Does that answer your question?
In a way, so I kind of need to connect two things. The system that you have and the decisions that you make. So it seems like you need to start from the analysis, and what will be the next step after you finish with the analysis? What the threats could be, the risk analysis or risk appetite, and then this data sensitivity. What will be the next step?
Yeah, once you've identified that, then decide how to build it. Do you want to, if you're building a fairly simple website, let's say I'm going to just want to I'm building a personal website and I want to display pictures. I may not need to put in, I may not want to worry about using zero trust internally within the network. So I might strike that. I may decide that the cost of and the WAF that you choose, you can turn it on optionally, but there are different levels. Do you want to use the less expensive version, which might be adequate for a standard for a standard business website? But if you've got sensitive data, if you're putting this in front of, let's say, a bank, you want to probably use the higher grade protection.
So does it make sense that we can think of it like there is a threat matrix and a solution?
Yep.
So we kind of know that each tool, and they're kind of like almost not overlapping, or if they overlap, like for example, WAF is provided with a level 4, and also it's provided with the front door. Then we need to choose which one we choose. So is there
Yep.
any is there any system that you would recommend to use, or like a matrix, or how would you approach practically the analysis? Would you just sit and analyze on your own, or you would do it differently?
Well, as a solution and as a solution and enterprise architect, I'm going to sit and look at also what is the business case behind it. You know, when I go to my CISO and my CIO and the executive board, what's going to meet their business needs? That's another big part of designing any solution is what are the business needs and what is your product owner's concerns? Are you addressing those? And if and again, how much risk can your business, and that's a business decision, how much risk will the business decide? And so you select your tools based on that. I will use I'll use a app gateway with at the front. I will put certificates between the app gateway and my applications in the back if I need it to be highly secure. In fact, I may want to say for my applications in the back, I'm only going to accept connections that come from the app gateway. I'm not going to accept connections that come from someplace else because we want to be very, because we've decided for our business, it's very important that it be very tightly secure.
So yeah, from that perspective, would you say that there is a standard package of tools that could be applied to standard looking businesses, that you could say, I have a typical solution and typical package of what businesses usually do?
Yeah, I tend to have a default pattern that I build to, and then I would select based on, well, am I highly of course, the two biggest certificates that I have are the CISSP and the CCSP, which makes me extra paranoid about maintaining security. And so I would tend to I would say, in almost any instance, I want to include that WAF to automate a lot of the defense against common web attacks. Now I'm Now I might not turn on the highest level on my personal website. I don't think I've turned on the WAF protection at all. I'm just letting I built my personal site is in AWS, and I just let CloudFront's default Azure's um, or default web application firewall be in place. I didn't turn on, didn't enable any of the extra layers of protection because an attacker's not going to get much by attacking my personal website. However, for many of my clients, I'm going to insist on that. We want to defend against the common attacks. And if we turn on on the basic protections, it actually gives us a good set of protections against those common attacks at not much extra expense. Does that sound good?
Thank you. I'm still curious how the typical solution would look like for a typical case, but I already asked too many questions, so
Yeah.
maybe I should just stay quiet. Thank you.
Well, no, those are great questions. Thank you. That was really good, Tony. Awesome answers. I have to imagine one of your challenges always is how deep do you want to go? Like, yeah, if you show me your entire infrastructure and I ask you a lot of questions, then I can go really, really deep. Yeah,
Well, and what are you building? Are you building total greenfield when you're doing
right.
this? Are you doing a data center migration to the cloud? Are you migrating to the cloud? Well, how much security you turn on in that case is going to be different. Uh, One of the clients I had for Sogeti when I was at was a health was Banner Medical, and they had a very strict set of controls, security controls. On any application, you must account for these 35 controls. Some of them not every control was applicable to any given solution. For example, the controls that are mobile specific, you don't need that on a back end service that runs entirely in the data center and doesn't connect to a mobile device. But you had to account for that and explicitly say, not applicable.
Yeah.
Or in some cases with legacy technologies, some legacy technologies that you port may not be amenable to some of the security you want. For example, your connections between some older versions of SQL and certain and software running old legacy connections to that SQL, you may not be able to turn on encryption in flight. Encrypt my connection. That might not be available.
Right. All good considerations. We're at about the hour mark. Wonder if it's okay if we stop the recording and then we award someone, one of our attendees, from a JetBrains license from our sponsor, JetBrains. And then if we have other questions, we can continue going down as long as Tony's available. Sound good? All right, great. I'm stopping the recording. Thanks, everyone, for coming. Don't go away. Just stop